Hey, good afternoon, everybody. We're going to get started with our webinar in less than 1 minute, so please hang tight. Well, good afternoon. Welcome to another edition of Turks, Tips, and Tricks. Today, we're going to take a look at a powerful tool called Simcenter 3D. Now, for our agenda, we're going to talk about Simcenter 3D as it goes to complexity. And we might not think about embracing complexity. That might be something that makes us a little bit afraid, but we're going to show you why it's of benefit to embrace the complexity, and then why and how SimCenter 3D is a tool for you. My name is Dan Turk, and I'm an application engineer with Geometric Solutions. The company that I work for, Geometric Solutions, we have an expression we like to say. We walk the talk. So it's not just that we can talk a good game. No, we walk a good game as well. So the tools that we're talking about are tools that we are actively using. So let's get started talking about SimCenter 3D. And the first thing we're going to talk about is this explosion of complexity. Now, consumers, myself included, you guys included as well, think about the things that you're interested in a product. You want it to be smart. You want it to be connected, personalized, efficient. At the same time, though, you want it to be sustainable, right? We want things that are green, good for the environment. Oh, by the way, it better have a great quality and it better not cost too much. This is the complexity that we're getting right now, that you guys are getting with your customers. When we take that complexity and then we bring in the typical things, getting to the market fast, getting to the market first, does that matter? Well, ask Tesla, ask Neil Armstrong, or having a good scope. So essentially, we make the products that our customers that they desire, and at a good quality and at a good cost. So we take this complexity with these normal problems that we have, and it makes it even more difficult for us to manage. We might think that this is an impossible problem. Lee Iacocca, though, he had something pretty interesting. He said that there's all these great opportunities. They're all in front of us. It's just that they're disguised, they're hidden as problems with no solutions. So just think about that for a moment. Some of the problems that we're facing right now. See, maybe we want to make something that's more powerful and yet it's better for the environment. It's faster and yet quieter, lighter yet stronger, thinner yet cooler, more complex, yet we can get it to the market faster. Now, typically, we would say, well, if you want something more powerful, what's the trade-offs, the engineering trade-offs? Well, if it's more powerful, it can't be greener. Or if it's faster, it can't be quieter. Well, that's where we have a tool like SimCenter 3D, where we can look at all of these problems and we can turn them into opportunities. So SimCenter 3D, you can see on the screen, we have this little engineering desktop. SimCenter 3D, it contains all of these different solvers. Now today, we're going to focus just on one, because some people will think about CAE or computer aided engineering and they'll think, well, that's an explosion of complexity in and of itself. Well, in our brief webinar today, I'm going to show you how you can simply use this tool and how you can use it for structures. Now, we'll have some future webinars where we'll talk about using thermal or flow or acoustics. The list goes on and on. But the key here is that with one tool, Simcenter 3D, we have the ability to do everything you see on this wheel. And we can do it at the same time with a multi-physics environment, and also we can do some design space exploration. So let's take a look at just a simple, typical situation. And we're going to look at a garlic press. Now, one of my colleagues, he had a garlic press that he really liked, and he used it so much, you can imagine how much cooking he was doing, that he broke it. So they went and bought a second one, and that one broke as well. And this really presented a nice situation. How could you improve this garlic press? How could you make it so it would work better? Well, that's what we're going to look at. We're going to take in this brief webinar, we're going to take and run a couple of minor structural analyses. So you can see some of the breaks, some of the problems. Well, we'll look and see at how we can improve on those. So with that, let's jump in to our Simcenter 3D. Now, the first thing to note is right now we're in NX modeling. Now, that's something I want you to note because most of you attend these webinars because I talk a lot about NX. Well, we're in NX and Simcenter 3D is driven by it. So I've got the garlic press, and we're going to look at just this one female handle by itself. Now, here's how I switch to Simcenter 3D. All I'm going to do is switch the environment, switch the application to pre and post, and voila, I'm now doing some FEA analysis. It was just that easy. But there's a couple things that we can do with Simcenter that you can't do with other programs. Now, the first thing is we're going to run a test on the neck of this garlic press. And then also, remember where those cracks were? We're going to run some tests up there. So in looking at this, we don't really need all of these holes that we have on this part. In fact, all those holes are going to do is it's going to just bog down or potentially bog down our meshing. So I'm going to create what we call an idealized part. Now, an idealized part, it's basically, this is the best case part for us to mesh and solve. So for our purposes, all these little holes, let's just get rid of them. So with just a button click or two, they're gone. That way we can speed up the process. Again, this is something that is very unique to Simcenter 3D. And as most of you know, since you use NX, we also have that modeling power behind it. But let's go ahead and mesh. So I'm going to create a new FEM file or finite element model. Now notice we have a whole bunch of different ones. Remember, I was talking about flow and thermal, but we're just going to stick with our Nastran solver. So we'll just stick with the defaults. All right, so here's our part, and we're now in the FEM model. You'll notice that on the Home tab, all of the buttons, they've changed. See, it's only going to show us the buttons that we actually need. The first thing we'll do is let's create a physical property. And for this one, I'm going to make one for steel. And I can see there's an inherited steel, so we'll just use that. And the next thing I'll do is create what we call a mesh collector. Now, a mesh collector, I like to think about it as a speed tool. Now, granted, we're doing a very simple analysis here. But this mesh collector, anything that we're creating, it's just going to be able to drop right into this one collector, or you could think of it as one bucket. So you don't have to look in multiple buckets to find what you're needing. We could even take that bucket that we had just created, and maybe we want to change what the mesh is going to look like. Now, when it comes to meshing, you're probably looking at the Home tab and saying, wow, there are a lot of options. And you're right. We could use a mapped surface where we can get a really fine detail on just one area. Or we could just use the 3D tetrahedral. So for this one, I'm just going to select the body, and you'll notice we've got this little lightning bolt where it will give me a suggestion on what the size could be. We've got some nice options where we can change the surface-based curvature, or even those really small features, we can adjust that as well. And remember I talked about the mesh collector, that speed tool? Well, we want this part to go inside the mesh collector. Now, what color did we set that to? Do you remember? It was kind of like a cyan color. Let's see if that's right. Yep, there we go. So just that quickly, what have we done? We've taken and we've meshed our part. So pretty amazing that we can do it that fast. Let's next work on solving. So the first thing we would do is we're going to create a new simulation file. And again, you can see all the different varieties. We're going to stick with the Nastran solver. And I'm just going to go with all of the defaults. We'll just create that solution. All right, so when you create a solution, a lot of times we think about it as you want to put a load and then you want to put a boundary or a constraint. So let's think about the load first. Now look at all the different load types that we have. Wow, there's even gravity. That's pretty cool. But for our purposes, maybe we would want to use force. So we want to use a force, and I'm going to put it at 150 newtons. And we know this guy is going to be going up. So we'll have it in that direction. And then I just want to choose an area where I want that force to go. So let's just say that I picked a node. You know, I used my eye and I tried to get in the middle, and there we go. Well, is that exactly what we would want? It's not really in the center. I mean, it's kind of there, but not precise. No, let's not use that. Let's take this a step further. And I'm going to show you a nice feature that we have in Simcenter 3D. So I'll just do a quick undo. And then I want to go back to the idealized part. So that's this guy. And from here, I simply want to create a sketch. And what I'm going to do is I'm going to create a circle where I can kind of divide my face so that the pressure or that force, I'm only going to have it go in one specific area. I'll pull that back just a hair. There we go. So I simply create a little sketch, divide a couple of faces, and then you can see it's almost like it's etched in. So we've got one on the top and one on the bottom. It went all the way through. So we're in the idealized part. Now we need to go back up. So what was the next one? Oh, that's right. That was the FEM model, finite element model. What's cool about this is as soon as you go into the FEM model, it says, wait a minute, something has changed, even though it's just a little bit of edging that's changed. We'll simply go ahead and click Update, and that's just going to reattach the mesh. So we're just remeshing this part. So on the bottom, yeah, that's what we want. That's where we're going to apply that load. Now the top, boy, we really don't need that, do we? So why complicate things? I'm simply going to merge these faces and we'll just get rid of that. That way we have a nice clean mesh. And that just highlights that with meshing, you know, I'm just showing you a couple of the options, but there are so many more. All right, what's the next step? We got to go up again. So let's go back to our simulation. Look at that. That's exactly what we wanted. Let's add the load. So I'll go with a force, 150. And for my object, I'm just picking that area where it's now defined. So then we can see graphically, this is where the load, this is where the force, where it's going to go. So that's the load. The next is the boundary, or you could think of it as a constraint. Now there are a number of different constraints that you could use. We're just going to use a couple of them just to kind of show. The first is a fixed constraint. So a fixed constraint means we don't want it to move. Now think about this garlic press. This is the female, the male was on top, and so they were coming together at that surface. So we'll say that that entire surface, that's going to be fixed. And graphically, you can see how it's fixed. Now again, in our brief webinar, we're going to just go through this kind of quick, but there's a load, there's a boundary, there's a constraint. And then we're going to actually take and solve this. Now, the nice thing about the solver is it does work rather quickly. We'll get a solution monitor that comes up, and it's just through text telling us what's going on. And usually on a simple part like this, it might take 20 or 30 seconds. The key here, though, is think about how much time it's going to save us in the long run running one of these analyses instead of just taking a guess, or we could say even worse, over-engineering a product. So we'll just let this keep on running, and it should be done any second now. There we go. So now it's complete, 43 seconds, so I was off by a few. And we also have this nice job monitor. Again, it's just another double check. That way we don't click out of something before we need to. From here, I'll go into the analysis. And I can load the structural analysis, and I'm going to go into the stress. And the first thing we like to do every time is we want to animate it. We just want to see, what is this thing doing? Now, granted, this is a very exaggerated animation. It's like exaggerated by 10%. But it does visually help us to see where those pressures are coming into play. Of course, you could change that so that we get something that's more realistic. So we're just seeing the pressures now, although visually that might be a little bit more difficult to see. We also have some nice options in here where we can take a look at maybe a banded display. So right now everything kind of blends together. Well, if we turn on the banding, it just makes it a little bit easier for us to see. Now keep in mind, we ran this analysis in really just less than 5 minutes, right? So that's just showing us that using Simcenter 3D, it doesn't have to be so difficult. In fact, what we encourage our customers to do is just to dip your toe in running a couple of simple analyses like this. So for our purposes, let's run another one. So I'm going to create a new solution, and we're going to keep all the defaults again. Now, the cool thing to note is that we haven't changed the part that we're in. We're still in the same one. It's just that we have a second solution. Now let's add the load. Now, do I need to go back up, remember which load I used, type all of that in? No. See, Simcenter 3D is really smart. So I'm able to go up to these containers and I can see, there was the force that I used. Let me use this in the active solution. And so now there it is. So it's helping us so we don't have to recreate everything. I'm going to use another constraint type, but this time I'm going to use a user-defined constraint. Now, this one is pretty impressive. You'll notice on the bottom we have 6 degrees of freedom. So it's X, Y, Z, and then rotational X, Y, Z. So I want to lock out the Z rotation. I want that fixed. And I'm also going to fix the X, Y, and Z directions. And graphically, you can see that constraint that was put on there. Let's go ahead and solve this one as well. The last one was, I think, wasn't it 43 seconds? We'll have this one race. We'll see which one gets done faster. But again, as this is cycling through, just think about some of the simple ways that you could use this tool and then expand from there. With what we're doing right now, we're running two different solutions on one part, but we could add to that. We could have even more. We could add thermal. We could add any other number of things that we might need. So we're getting up to the time any second now, and it should be complete for us. There we go, 44 seconds. So the second one lost by 1 second. We'll just make sure our job is complete. Yeah, that looks good. And from here, let's go back to our analysis, but this time solution number 2. And there we can see some kind of bright red. If you recall from those pictures, this is some of the area where we were having trouble. So let's just play out the scenario. We've run the analysis. We've seen that, okay, we need to fix a couple of these areas. So in a typical sense, what would you do? Well, you would contact the designer and you would tell him, here's the changes I want you to make, and then I'm going to rerun the analysis. Now, hopefully your designer is not out to lunch or on vacation or on the other side of the world. If that's the case, you might be waiting for a while. You see, here's another way where Simcenter 3D, where it can do things that other programs cannot. And that is that we can change the model ourselves, and we can change it right on the fly. So to improve the neck, what might we do? Maybe we would say, let's take the size of this and just make it a little bit bigger. How about 2 millimeters? That looks good. And what about this radius? It's at 1, but what if we took it, let's double it. Let's take that to 2. And up at the top, that's 2.5. I'm just going to key in 3.5. And I want to add a little edge blend on each one of these. At 2, that's good. And that model, it's complete. In the time it would have taken to send the email with the request, we just did it ourselves. All right, we're at the bottom in the idealized part. Remember, we got to go up. So we'll next go to our FEM model. And we get that nice little information window. Watch out, something's changed. But here's what's cool about this. It's actually showing us with this kind of ghosting what has changed. So we simply will update the model, update the mesh rather. And look at that. Do you remember when we merged that surface or merged that face? We don't have to do it again. It remembered what happened and knows what to do. From here, we would go back up another level to our sim model. And at this point, we would actually take and we would resolve each one of those solutions. So solution 1, solution 2, and then we would get the results that we have. Now for our purposes, our webinar, we're almost out of time, so I'm not going to do that right now because that would take another minute or two. But just to show how you can very quickly and easily run multiple analyses on a part. And that's really what's important, isn't it? When we think about Simcenter 3D driven by NX, just imagine what you could do with a tool like this to be able to get those insights earlier. So we didn't have to make 10 prototypes to know which one's going to work. Maybe we'll just make one prototype. Or we can innovate faster because we're doing everything in the digital twin, in the digital world. That's going to lead to greater productivity, and of course, we're going to have a really nice ROI. But for me and you, or I should say for you and I, the better products might be the key because we're consumers too. We'll be able to put out better products. Why? Because we're not racing to get something out the door at the last minute. No, we've utilized the complexity. We've embraced it by using a tool like Simcenter. Just to point out again, we focused very briefly on the mechanical, but would you like to see the fluids and the thermal, electronics, physical testing systems, or maybe some advanced topology optimization? Well, we're going to do some of that in our upcoming webinars focused on SimCenter 3D. Now with that, I'll look to see if we have any questions. And at this point, we don't. If you do have any questions later, please just shoot me an email and let me know. I want to remind everyone that Turks Tips and Tricks, we do this the fourth Tuesday of each month. Now, usually we focus on NX, but I thought it was kind of cool to mix it up a little bit. Do you have a suggestion for Turks Tips and Tricks? Well, if you do, send me an email at dan.turk@goplm.com. And if I use your suggestion, I'll send you a pair of these stylish nerd glasses so you can look like me. Are you interested in any training? Well, there again, dan.turk@goplm.com. At this time, I'd like to thank everyone for your time and for your attention. If you'd like to learn more, you can send us an email, or you could scan this little QR code to learn more about our upcoming events and more about geometric solutions. Again, I'd like to thank everyone. Have a great day, and as always, be safe.